Hey everyone, and welcome to The Explainer. Today, we're on a real mission. We are going to take what might normally look like, kind of a dry technical lab manual and completely transform it into a super practical, step-by-step guide for building a functional Android login application. So if you've ever wondered how to stitch together user authentication without setting up some massive, complicated backend server, well, you're in exactly the right place. Let's get into it. Okay, let's dive into this incredibly universal developer problem. Think about it. You open an app, you log in, you close it, and then when you open it back up hours later, you're still logged in, right? So how does the app actually remember you across different sessions without constantly pinging a complex database in the background? Well, the answer in the Android ecosystem is something called shared preferences. I want you to think of this as your app's digital safe. It's basically a very lightweight built-in lockbox that's specifically designed to store your app's absolute essential key value pairs. And we're talking basic data types here, okay? Things like strings for usernames, booleans for login status, maybe a few integers. It is definitely not a heavy relational database, and honestly, that is exactly its superpower. All right, here is our blueprint for today. We'll start with number 1, what shared preferences are. Then 2, setting up your project. 3, building the session manager. 4, the register and login flow. 5, the user profile page. And finally, number 6, a really cool next level challenge for you. Let's start right in with section 1, what are shared preferences? So why are we using this specific tool for our simple login app? Well, the minimal requirements here perfectly illustrate why shared preferences is absolutely perfect for what we're building. For a basic login screen, we only really need to store minimal data, like a username and a password. And by keeping the data footprint incredibly small, our app stays super fast. We basically get that persistent session behavior that users expect, but we completely sidestep all the headache and overhead of a full SQL database setup. It's a total win-win. With the theory down, let's move on to section 2, setting up your project. Every great app needs a solid foundation, and our blank canvas begins right here in Android Studio. To kick off this project, you just open up the IDE, select Create a New Project, and you specifically want to choose the Empty Views activity. This is going to give us a completely clean slate so we can build our login interface from the ground up. Let's see how this all comes together using the quick setup guide we pulled straight from the lab manual. It's a really straightforward 5-step process. First, we create the project. Second, we add 2 new activities, one for login and one for register. Third, we create a helper Java class, we'll call ours Preferences, to act as our session manager. Fourth, we initialize the shared preferences in the code. And finally, step 5, we use the editor.apply command to actually save our data. It's an incredibly logical sequence when you break it down like that. And what's really interesting here is seeing the actual anatomy of the app visualized perfectly. Look under our Java folder. We've got our visual dates, the login, register, and main activity classes, and sitting right alongside them is our backend brain, the Preferences Java class. This clean separation of concerns is exactly what makes our app so much easier to manage as it grows. Let's transition over to section 3, building the session manager. This is the backend brain where the real magic of local storage happens. Our Preferences.java class is simply a collection of core functions. And you can probably see a pattern here, right? It's all setters and getters. We have methods to set and get the username, the password, the logged-in user, and the login status. Oh, and there's also a crucial clear logged user method for when we want to log out. Now, instead of getting totally bogged down in all the Java syntax, I just want you to understand that these methods are simply instructions for putting specific items into our digital safe and taking them back out when we need them. That's it. The crucial point to remember is how this code actually translates to plain English. Whenever you want to save something, you open the editor using sv.edit. Then, you literally write down the key value pair. Think of it like a label and the data itself, using something like putString. And finally, you securely lock the safe by hitting .apply. If you grasp that simple 3-step concept, you've totally mastered shared preferences. Moving right along, let's hit section 4, register and login flow. These are the visual gates of our app. This is where the user actually interacts with all that logic we just built. Here are our visual mile markers. On the left, we have our nice, clean login UI, asking for an email and a password. On the right, the register UI, which adds that absolutely crucial confirm password field. These XML layouts are tied directly to our Java classes, effectively creating the bridge between what the user sees and our digital safe behind the scenes. So let's talk about the registration logic inside our register.java file. Before we let anyone just go in and put data into our safe, we absolutely have to validate it. The app first checks if the fields are empty. If they are, boom, it throws an error. Nobody gets in with a blank name. Then it uses a custom method called userExistsIs to double-check the shared preferences and make sure the username isn't already taken. Next, it confirms the passwords match perfectly. Only when all of those crucial checks pass smoothly do we actually call our preferences.setUsername and setPassword methods to lock those brand new credentials away securely. And the login flow? Well, it's essentially the mirror image of registration. When the user tries to log in, login.java makes sure the fields aren't empty, and then it validates their input directly against what's already locked inside our shared preferences. It checks that the username exists and if the password is a match. If it all checks out, it sets our status login boolean to true, which means the session is now active, and it triggers the goLogin method to redirect the user. And where exactly does that redirect take them? To Section 5, the user profile page. This is the final destination for our successfully authenticated user. It's kind of our climax. A beautifully simple, clean profile page showing that the session is active. Over in mainActivity.java, the app reaches into shared preferences, pulls out the active user's name, and displays it right on the screen. It's solid proof that our local storage is working flawlessly across different activities in the app. But, what goes up must come down. The logout process is equally elegant. When the user taps that logout button, it triggers that preferences.clearLoggedUser method we mentioned earlier. This method acts kind of like a selective memory wipe. It uses editor remove to completely wipe the active user and login status keys from the safe. This securely ends the session and seamlessly returns the user right back to the login gates. So you now have a fully functional authentication system, but we are definitely not stopping there. Let's look at Section 6, the next level challenge. This is based on Practice 2 in the manual, and it's time to take the training wheels off. Your challenge is to modify this project on your own. I want you to go into your register layout and add 2 more input fields, let's say address and phone number. You'll need to create the new setter and getter methods in your session manager to handle these new strings. And finally, display this branding information on the profile page once the user logs in. Trust me, it is the absolute best way to cement these concepts in your mind. Which brings us to our final thought for today. We've used shared preferences in this explainer strictly for authentication, but I want you to think bigger. What about high scores in a simple mobile game? Or saving a user's dark mode preference? What about their default language setting? Beyond just logins, what other lightweight, essential user data could you lock inside your app's digital safe to make the user experience absolutely seamless? Keep experimenting, keep building, and I will see you in the next explainer.